class, welcome back. We have another video today on piecewise functions. However, we're going further, okay? We are going to start graphing piecewise functions. So before I start, just to let you guys know, especially if you're one of those people that are color coding everything, which is great, I love that. I do that too. But make sure you have a pencil with an eraser handy because there will be some erasing happening in the video, okay? So again, I don't really want you to remember any precise definition of piecewise function, except kind of that you know that it's made up of pieces, right? So piecewise functions are a combination of pieces, all right, of pieces of functions to create a single function. Okay, and if you remember, we can say that it's going to create a single function. Why? Because it's going to pass the vertical line test. It's going to pass the vertical line test, which means it's a function, which means there can be no overlap. And that is why we will need our eraser in a little bit. Okay, so let's take a look here at example number 1. What does it say to do? It says we're going to graph the piecewise function and then state the domain range. Okay, so we have a function. It's made up of two lines. How do we know this? Exponent of 1, right? So we have two linear functions here. I'm going to graph them. All right, -3/2 x minus 7. That means I have a y-intercept of -7. And then I have a slope of -3/2, so it's going downhill, so down 3/2, or back 2, up 3, etc., 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 etc. Okay? So, this would be our line if it was just f of x is equal to -3/2 x minus 7. But what you have to keep in mind here is that it is kind of restricting the domain for this function. It's saying that this is only going to occur when x is less than -2. So when we kind of sketch this, right, when we sketch our line, oh, I made a wrong point. Sorry about that, guys. All right, when we sketch this, we kind of have to think through this a little bit. We only want when it's left or less than -2, which ends up being right here. So what I'm going to do is I'm going to erase everything to the right. All right? And then we need to think about this a little more. If it's x is less than -2, is this point occurring? No, it is not. We need to erase this point as well. We need to make this an open bubble. And why is that? Because when x is actually -2, it's going to use the other function. All right? So now that we have the shape sketched, we're going to go ahead, we're going to finish up by making that darker. All right? Now, what happens on this next one? We have another another linear equation, 1/2 x minus 3. All right, so we have a y-intercept of -3. And we have slope of 1/2, so up 1/2, over 2, etc., or this way. Okay, and again, we would sketch this line. What do you guys think you're going to be able to start getting the hang of doing pretty quickly? Do I need to draw this entire line in? I don't even know if you guys can see that. Shoot. Yeah, we can see that now. Okay. Am I going to need to start drawing this entire line in? No. We know that this graph, or this line, this function, the piece, is going to start right at -2, which means I'm already going to say I'm going to get rid of the left side. Okay. Now, we have some things to think about here. This one is x is greater than or equal to -2. So the point that I have right here at -2, -4 Would I bubble that in or would I leave it open? I would bubble it in. Why do I bubble it in? Because x is -2 here. It can be -2, so that means I would put a closed circle. And then I would draw the sketch of my line. Okay? Alright, get the eraser marks out of there. Alright. So now that we have this sketched, we can go ahead and we can think about the domain and the range. Well, domain, we know, is all x values. Range is all y values. Let's take a look. Domain, I'm coming from left to right, -infinity, right? It's going to the left forever, so -infinity. Is there ever a place where my x cannot be? No. So this one is going to be -infinity to infinity. Now be real careful here. If there had been a hole here, and then the other graph didn't fill it in, well then you would have to worry about that. Then you would have to mention that in your domain. But because there was a hole from one side of the piecewise, and then it filled in on the other side, we are all good. Okay? Now for range. Same idea. Alright, my lowest point right here is at -4. And then I know I go up forever. What bracket do I put a bracket or do I put a parenthesis here? I need to put a bracket because it is filled in from my second piece. Alright, so even though the first piece it would have been open for, because it is occurring at I have a y value of -4 because of the second piece, I have to bracket it. Okay? So this is one way of doing it. With lines, there's another way, and I do want to show you that now, just so that you guys can kind of understand that there are two ways to do these. So when we move down to our next example, one thing that we can also do here is we can work with the boundary points. Okay, now I know this first piece right here, this is going to be a constant or a horizontal line. And I know it's going to start where? Or it's going to go or be where x is less than 3. So if my boundary is at 3, right here, well then I know that right here at 3, 7 is going to be my point, and then I would have my line kind of like that. Okay? Now let's think about this for a second. Is it going to be open or closed? It is going to be open, right? That's bad. It is going to be open because x is not actually hitting 3 from the first piece. So I would go ahead and I would just sketch this from the boundary point to the left. What else I could do is now I can move on to the next piece, and I can find the boundary point. Like if I plug in 3, 3 minus 8 is -5. Alright, so I know that there is going to be a point at 3, -5. Now my question is, should that be bubbled in or should that be an open circle? This should be bubbled in because x can be 3, or will be 3 I should say, for this second piece. So I'm going to bubble it in, and this is the trick. I don't need to find the y-intercept and plot my line. I know that this is a point, and I know the slope is 1. So this is almost more of the point-slope approach, whereas what we did up in the first example was more of the slope-intercept, where you had to find the intercept, graph the line, and then erase. This one now, if you can find a point, and you know the slope, you can determine the line. So I bubble, and then I draw. Alright. This is kind of hard to see. Let me see if I can make that a little darker. Alright. Okay. Hopefully that makes sense. Again, how did I know that I didn't have to draw the entire line? Well, I knew I was picking up at 3 and then going to the right forever. So I just had to go to this point and then use my slope to finish off the line. Okay? Well, again, domain is x, range is y. My domain here, I'm starting at negative infinity. I'm coming to the right, 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 right. Okay, here's my danger spot, right at x equals 3. But even though it's not hitting 3 here, I do have an x value of 3 here. So it never, ever stops my x values. So once again, negative infinity to infinity. My range, I have a closed circle right here at negative 5. So a closed circle means I will have a bracket. And even though this one really is only hitting positive 7, my blue piece, or my second piece, is going up forever. So I have to consider both when I'm finding my range. Alright, let's try some more examples. Ooh, this one's good. This one's good. So this first one, or I guess now the third one, has 3 pieces now, okay? So we have more work to do. I want you guys to kind of pick a method and stick with it. Alright? If you like to graph the line because you know that this is the y-intercept and this is the slope, then do it. Alright? Whatever you think is easier is what I want you to do. So let's take a look here. Negative 2x minus 11. Negative 2x minus 11. Well, that means I have a y-intercept of negative 11, or something right about there. And then my slope is negative 2. So that means it should be going down. So either I go down and to the right, or I go up and to the left. So that's what I'm going to do. I'm going to go up 2 over 1. Alright, and then I sketch. So I know what this line is going to look like. Now, what do we have to keep in mind? This is only good when x is less than negative 2. So that means I can get rid of all this. And now I have to decide, right at negative 2, should I have an open or should I have a closed dot? And the answer is, hopefully you all said open. Yeah, this one has to be open, right? Because it's not actually hitting negative 2. So, I bubble. I extend, I put my arrowhead on there, and I am done with that piece. I move on to the next part. Alright, 3 halves x plus 2. Well, I have a y-intercept of 2. I know my slope is 3 halves, so I'm going to go up 3 over 2, up 3 over 2. I can't do that one. Down 3, back 2. Do I need to keep going? Hopefully you guys agree. No. I know I can't overlap, so this is really the farthest I have to go to the left. Alright, let's take a look at what's going to happen here. It is actually occurring at negative 2. This piece of the function is occurring at x equals negative 2, which means I need to bubble. And then at 4, it's not occurring, right? So I have to put an open. And then I can create my sketch. Now real quick, just be careful. I would go ahead and erase that dot just so I know for sure that it is an open circle. Same thing with this one, just to make sure. Okay, good. Alright, almost done with this one. Now we know that when x is greater than 4, the y value will be 3, or we'll have a horizontal line. So, horizontal line at 4, from 4 at 3 will be something like this. And we have to decide now, is it occurring when x is 4? No. No, 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 no. So that means I need an open circle and then extend my line to the right. Alright? Perfect. Beautiful graph. Let's take a look and see what's going on here. So again, my domain is x's, range is y. Domain, negative infinity, right? It's going left forever. So negative infinity, we're good, we're good, we're good, we're good. We're good here because even though it drops off here, it picks right back up. This is good. Ooh, right here at 4, do you notice how there are open circles at both? That means that there is never an x value of 4 that exists on this piecewise. So we have to take that into consideration when we write our domain. negative infinity to positive 4, then pick right back up to go to infinity. Range, sorry about that, guys, range. Let's see here. Negative 7, and then we go up forever, forever, forever. Oh, we go up forever. Okay, so it's going to go to infinity. We have to decide, open or closed. Open. There is not going to be a y value of negative 7, okay, because it's an open circle there. Alright, last one. This one is going to be a little more challenging because now we have a parabola. Okay, these aren't always just going to be lines. So this is a good example. Get you start thinking about how this will work with parabolas as well. So let's think about this. We know what transformations are occurring here. We know we're going left 4 and down 6. Oh, my bad, guys. Okay, so one more time here. Left 4, down 6. So I know that I can plot my point left 4, down 6 right there. Okay. What else can we do? Well, this is a parabola. We can use our growth factor. You can write it out. I'm hoping you're getting better at these where you just know that a growth pattern for a parabola is 1, 1, 1, 3, 1, 5, 1, 7. Okay? So let's get our pencil just to make sure we don't mess this up. Over 1 up 1, over 1 up 3, over 1 up 5, over 1 up 7, and then you can go back the same way. Okay, so we have our points. We know what this is going to look like. We have to decide now where we're going to have to erase and what is good. So I sketch my parabola with my pencil. I know that it will go up forever in both directions, and then I look at the boundary. The boundary is 0. I know that this shape is only occurring, this parabola is only occurring where x is less than 0, which means I get rid of my arrow. And I put what type of marking at x is equal to 0? Do I put an open or a closed? I put an open circle. And now I can draw this section of the graph. Not my best parabola, but it'll do. Okay, cool. Hopefully this makes sense, right? This is a parabola. Normally it would go up forever on the right side, but because it is stopping at 0, we stop it at 0. Next piece, oh, we're back to a line. This is good. We can go either route. We can get the boundary point. I guess in this case it's going to be the same thing. We know that our boundary is at 0, so it's really just getting the y-intercept. Let's see here then. Y-intercept of -1. Slope of 1/2. Up 1 over 2. Up 1 over 2 over 2. Okay. And we decide, what do we have to do here? Alright. Hopefully we agree. I didn't even need to make any points to the left. Why? Because I can't overlap with my parabola. I cannot overlap with my parabola. So my last question before we go to our color is, what type of circle will it be? Will it be a closed point or an open point? And the answer is open. It is an open point, and the reason is because x cannot be 0. Alright, we finish by getting our domain and our range. Our domain here, well, let's see here. We are going to the left forever because of our parabola, and then we're coming over. Ooh, I have 2 open circles at x equals 0, so we do not include 0. There is no x value of 0. For the range, what are we thinking here? We have a y value of -6. It's going up forever on either graph, really, so we know it's going to positive infinity. The real question is, what bracket? Open or closed? Closed, because I actually have a point with a y value of -6. Alright, so this is a good introduction to graphing piecewise functions. Hopefully it's making sense. Of course, we're going to practice this a ton. It is very challenging. I hope you guys have a great day, and I'll see you later.